Hello, my name is Kevin. Nice to meet you. As previously stated, I'd like to introduce you guys to Scouter, which is a centralized search engine for ticketing systems. And it was also serving as my bachelor's thesis that I could luckily do at 9. So thanks for 9 for giving me the opportunity for that. I'd like to go through the points that I'm going to go through next. First, I want to answer the question, why bother? Like, what is it for? And then I'd like to show you a demonstration. I'd like to inform you about the used technologies. There's 2 main objectives. The first one is archiving. The second one is the search engine part. At the end, I want to evaluate and show you what are the pros and cons. And then I want to inform you about the next steps that are ahead of us. So why bother? The first main objective is the archiving part. And the biggest use is to essentially stop the ticketing systems that are currently still running just for data access. So we have changed the data and the ticketing systems a couple of times, and they're still running just so we have data access, which is actually not very cost effective. Also, the data can still be changed, so it's not really archived, and the integrity is therefore insufficient. The second part is the search engine. In the IT support, people want to search for reference cases, so they know how to solve issues that they had in the past. And currently, they have to go on every distinct ticketing system. And as previously stated, it was a couple of times changed already in 9. And the big part is to centralize it into one tool. And currently, there's no way to influence the relevance of the tickets, which means if I find a ticket and it helps me with my case that I have, I cannot tell the system that it's the very ticket that really helped me in that specific case. So that's another big point. And yeah, last but not least, also it was my bachelor's thesis. Next up, I want to show you a demonstration to show you how Scouter looks like and yeah, what it can do. So first up, if I open the search engine, I can log in, make it a bit bigger. Can you see now? Good. I can use my email address, and you see there's no password, so at the moment there's no authentication. You can just log in with your email address using a pseudo user for this. And then I have to make it a bit smaller so you can see everything. Just for the overview, so on the left part, you have the search, and with all the filters and everything, the search results will appear here. Here you have a very handy feature like the last opened tickets, and next to it the most interactive tickets and the newest tickets of both systems. I chose Jira and OTRS, which are both used as ticketing systems in the company. So now I'll zoom in because I can see you cannot really read it from the back. So here I can search for example, for SSL, because we have a lot of certificates we need to update in 9, and that's a very common case. So I can search for the keyword SSL, and then I get a search result on the left, which is a ticket that might help me. Like, for example, I'm on a call with a customer, or I have a ticket, and I don't know how to update SSL certificates. So I'm actually looking up how I can do that, and I'm using a query search, right? So now I have an example of a ticket that I can open now. And here again, I'm going to zoom out a little bit. On the left side, I have a general information. The conversation is also here. I can link tickets together. I can annotate them. For example, there's already an annotation that was very helpful for Paul in the past already, and he gave it a thumbs up, so it's a very helpful ticket. What I can also see is a very important context, GitLab, because we have a lot of code changes that are relevant, and they are also shown for context here. So what I can do now, I can go through the GitLab changes, and I can see something that was relevant for me. And then I can also like add a new annotation. I have used this to update an SSL certificate, for example. And I can store the annotation. And then, of course, if I search for it, I can see here that it appears in the annotations, the word. So it's a hit highlighting, it's called. It's also a feature that is prominent here. Yeah, that's pretty much it. I mean, I can see here with the I symbol that I opened it before. So for example, if I open the ticket SVC 456 and then go back, it appears in the last opened on top. That's a very handy feature. This is also a feature that is not available in the ticketing systems themselves. Also a very handy function here is the dark mode. It's very important, I know. Yeah, I started actually with the dark mode. No, not really. But it wasn't part of the thesis because yeah, it's just a bit of a game. But this is also stored for the user. So back to the presentation. Which technologies have I used? The main part was written in Ruby on Rails, the application itself, which I used the Sunspot gem. This is actually used to connect to the Apache Solar Index. A GitLab gem to get the context information from GitLab, from the REST API. And also the database management systems were relevant because Jira and OTRS, they both had their own databases. Next up, the archiving. What was the approach? Well, a big part of my thesis was to figure out how can you archive data properly, what can you use? And in this context, it was very clear to me, very evident that using database dumps would be the best solution. Because if I create a database dump, I get all of the SQL statements that are relevant to created tables and the database exactly in the same way that it was created before. And interestingly enough, I have not, sorry about this. I have not found any papers that used that for archiving. So that was very interesting. Maybe I didn't find any, but yeah. So I took database dumps and I actually analyzed if it's useful to be able to archive data. And yes, it's very, very useful for it. So what I essentially did on the Jira and OTRS systems, I created from the database management systems, I created a backup and stored it on the target server, on the file system. And the database dumps, they just stay there. They are not being touched anymore. And they are automatically backupped by our systems. And then I just restored it onto the same database management system on the server. That's essentially what I did. It's very simple, yet effective. And what is very important in the application, the data is only loaded in read-only. So the integrity that I mentioned earlier is actually handled with. So the data concept, the main data from the tickets comes from the ticketing systems. Again, I chose OTRS and Jira. The data is stored on the new DBMS systems on the target server. And additional data can be added through Scouter, which is annotations, rankings, and whatnot. And that data is also stored on the Postgres instance. But the original data for the tickets is not touched, so for integrity reasons. I identified a few requirements that I'd like to go through. So a good archiving system retains the meaning, the semantic context, and the metadata of the information. And because I'm using database dumps, all of this is actually dealt with. Because the semantic context, the information in which table it is stored is all retained. So you can always go back and understand what the data was meant for. It should be stored in a simple format, and it should be independent of the storage medium, which is also given because the format for database dumps is SQL statements, and SQL statements can be human readable because they're basically English. And yeah, I mean, the database dumps don't depend on the storage medium. They only depend on the database management system. And I'm pretty sure they're gonna stay for a little longer, MySQL and Postgres. The data should be able to be read, so viewed, searched, exported, and also looked at with a simple interface. Well, the Scouter search engine that you saw gives you a very good interface to search, right? That's its main use. But you can also go on the database management systems on the target server and just query the database with SQL. So you kind of get the best of both worlds, because the search engine only has a part of the data that is actually needed there. So the whole data is still in the dump available. Also, we have a backup and recovery concept, because we back up the whole file system on managed servers by 9. And also the recovery is dealt with. Migration can be done with the database dumps yet again. And the replication is something that I did not deal with yet. So therefore, this requirement is not really fulfilled yet. So yeah, that's something that we would need to look into to have a proper archiving system. And the technologies should be interchangeable. Yes, that's the case, because I can swap Solr with Elasticsearch. I can rewrite the code in like Java, for example, although not many people here are fans, maybe, I don't know. But yeah, we can essentially exchange all of the technologies. Next up, the search engine part. What was the approach here? Well, the active record from Ruby allows for a very simple data mapping. I can essentially just define what fields in which table should be mapped to the model, which is very handy. And the GitLab chat we can see here connects to the GitLab server and provides a very simple interface for that. And the Apache Solr index can be read and written to by Sunspot, which I will show in a minute how that works. And we can see here the application through Active Record loads the data that is on MySQL and Postgres. And yeah, that's essentially how it works. Again, simple yet effective. And if I want to actually add a system that is still running, because this whole concept is actually only working or only thought of by servers that were already shut down. So there's only one time that I load the dump and so forth. What I can do instead of reading it from the database management system of the target server, I could simply directly go to the still running system. So yeah, that's another cool thing, because it still works that way also. So what is the search engine? Like, what kind of search engine are we dealing with here? So what I have identified in my research is that enterprise search is a research field that deals with search in companies, which is very different from search in the World Wide Web. And the search engine actually allows for enterprise search, because you can search for data that is in the company. It is also a knowledge management system, which facilitates enterprise search, but also adds new data that has not previously been available. And you can annotate, you can link tickets together over multiple systems and everything. So it's also generating data that is very helpful. And it is a domain-specific search engine, which simply means it's like targeted to a specific domain. And in this case, it's the IT support of the 9 Internet Solutions AG. So what features does it actually provide, the search engine? So the search results are ranked according to the relevance, and you can influence the relevance by annotating, by rating. Also, the last open tickets are higher ranked. So that's very cool. The more interactions people have with the search engine, the better the results should be over time. There's hit highlighting that we saw earlier. So it's just in bold, like the text that was found is written in bold. We have search filters. We have conditional operators and all that stuff, phrases with quotes, wildcard search, fuzzy search, everything that Apache Solr provides. And also faceted search would be theoretically possible, which is narrowing down the search by dynamic filters. But this is not yet implemented in Scouter. It's a future feature. Next up, there's a lot of personalization features. First off, the login by email that I showed. You can rate the tickets, positive or negative. You can annotate them, and you have a history of last open tickets. And all of the stuff that is stored is always linked to the user that created it. So you can see who annotated and so forth. What were the requirements I have found for search engines, specifically for this case? Well, it should offer a optimized user interface. It should be sorted by relevance, and it should have modern features, which is all, again, checked. It should be personalized, and you should be able to influence the relevance by interacting with the search engine. It's also given. You should be able to centralize the search, which means you don't have to go into each individual ticketing system, but you should actually be able to search from one point and have the data centralized, which is also given. If you want to integrate it into other tools, it would be needed to have a REST API, which would be really cool, but that is not yet given. And it shows relevant context of tickets, which is GitLab, other tickets that are linked, and so forth. Next up, I want to go a bit more into the detail of Sunspot, which was a very cool Ruby gem that I used. Essentially, the search results are split into hits and results. So essentially, the highlights, for example, or the search engine relevant information you get from the hits, and the results is just the model loaded with the ID, and that's very handy because then you can just look up the show the results in the UI. It was very cool. And there's a seamless integration into the Ruby on Rails active models. We can see on the next slides how that works. You can just say which fields should be searchable and how important they should be and so forth. And the index can be updated very easily. You can automatically, so that doesn't work in my case, unfortunately, because the data shouldn't be changed anymore of the tickets. But if you were to change the model, then you should actually get an automatic update. You can also just manually update the search index by calling a command in the rate job. Next up, how do you actually define what should be indexed? You can see there's a searchable block. I'll go to the side to show. You have an ID that is an integer. Then you can define a title. You can say stored should be true, which just means that it can be highlighted. If you don't do that, you cannot highlight. You can have multiple messages, and you can map them from a different model to the main model. For example, the messages are not in the ticket model, but in a different model. And the ratings, you can also sum them up here, which will save time later. Like you have two options essentially. You could either, when you search, you could sum it up, which would be really slow because on every search you would have to do it. You can do it on the index itself as a different field, and I would really suggest to do that. Next up, how do you query the index? There's also, again, a very handy API for that. You have a Sunspot search command you can call. Then you can just tell it like which tickets are you willing to search. Then you can define like which fields should be highlighted. So for example, the title is going to be bold if it's your search query is actually in the title. Same goes for messages, for example. You can say the title should be slightly more important than the messages. And then here you can define the rating should be used as a boost as well. You can filter, and pagination is also done very, very easily. I've had a few issues when I was working with Sunspot, though, because it was not very self-explanatory to me. There's a README that is really good, but one part that I did not understand for a very long time is why doesn't it work? Because I did not use the schema that Sunspot is providing, and it was never written anywhere that I need to use their schema. So that took me quite a while to figure that out. So they have on their GitHub page, they have a specific schema that you need to use in Solar. So another problem there was they're not officially yet supporting Solar 9, which is probably because they're not really working on the project anymore. I had to do very minute changes, but anyway, I still needed to change it. So that was a bit tricky. Also, the boosting functions are not really very easy to understand, which is more of a problem with Solar, not with Sunspot. And again, as I said before, you should not have very complex boosting functions. I would prefer to store more data into the index, so it's only done once on index time. And updating the index is very slow with the amount of data we have. I don't really know exactly what the problem is, but it can be solved by updating the index with a job and then do it later, because you don't need to immediately see the changes in the search engine, usually. I'd like to evaluate real quick what are the positives and negatives. In my opinion, it is very cost effective because the old ticketing system can be turned off. Also, licensing costs can be reduced. The centralized search should make the IT support more effective. The support employees should be more able to work alone a bit more. And the data should be centralized and can also be used for other projects, which we will later hear from. Negatives, unfortunately, there's not only positives. You need to, if you add a new system, you do the data mapping every time, like new, if it's a different system. So complex engineering is necessary, unfortunately. And you have to have an individual solution for every source system, which is also a bit sad. But yeah, that's the negatives. What are the next steps? Obviously, adding more source systems, right? Because why only ticketing systems? Why not the wiki or docs or docs.9ch page, GitLab? I mean, indexing the GitLab, because that's not done yet, which could be very cool, because then you have everything centralized on one point and you can search and get everything. Searching the index is really fast. We should distinguish between internal and external information, because if we do that, we can show the public information on the website, and we can allow the clients also to search the search engine. But currently, it's only internal information which we cannot share. We should be adding more personalization features. For example, Sophie, when I was showing her how it works, she explained to me why do the last open tickets, why are they more important in the search? And she told me that that's maybe not what you want, because then you always open the same tickets over and over again. So that could be a feature that you could turn on or off, for example. More stuff like that. And more context. Also, the last search queries could be very informal for the search, which I'm currently not using. And also authentication, proper authentication, and SSO search. Adding more filters. I skipped that, unfortunately. Also, faceted search would be cool to dynamically narrow down the search. And updating the index in a job as opposed to doing it directly. I would like to thank you for your attention. And this is also why I call it Sculpture. This is a reference to Dragon Ball, if anybody knows it. It's to see the power levels of your enemies. And I just thought it was a cool name because you're looking specifically for an information. That was it. Thank you. Are there any questions? Quite. Okay, yeah.
When you searched before, you had a result super fast. I'm just curious, how much data is this searching over when you're clicking the search button?
Well, that's probably about 50 tickets because it's running locally.
Okay.
But on the staging, we have data that is actually from the servers, like 1 million tickets or something. And it's also searching in the index is really fast, but adapting the index is a bit slower, But the searching is really fast. Like it's almost the same time that it takes.
You have also the information from GitLab in the search
result. Yeah.
Is this also indexed and stored in the database, or is this gathered right at the moment you search?
It's not gathered when you search, it's gathered when you open a ticket. But in the future, it would be very beneficial to index it as well, because then you can search it, you can link it together also manually. But that was out of the scope of my thesis. It would have been too much. But yeah, very good question. Yeah. Yeah, Tom.
if you wanted to add another source like GitHub or something, what's the like process of that then to add another kind of system into the thing? You said it's kind of complex, but what does that mean?
You would have to do the same essentially that I did for those systems. I mean, the main application, of course, is there, but you need to create the models where you load the data into, and also you need to decide. Not every system that you want to add, you want to use the database. You would maybe also use the API. You need to, if it's still in use, you need to make sure that the index is updated, which probably would make sense to go through all of the data that has changed since the last time you updated the index. So some engineering would be needed there as well. I thought it through, but I have not added any source system yet. So there's probably going to be a bit more pitfalls. I can also write it on the whiteboard, but it's not going to be on the, you know. Does that answer your question? Okay, yeah. Yeah, Pavel?
Question about GitHub or GitLab.
Yeah.
For me, is there any way, are there plans to include, I don't know, search within Git commits or merge requests, like the messages, and have that in that system? And if so, that probably like updating this information in companies will be difficult because we are updating like crazy repositories.
I think I also thought at some point, like in the beginning, I just thought, all the commits and all the merge requests, but no, that's not going to be possible. That's way too much information. I agree. You have an API that you can call still and use that somehow, you know, for the commits separately. Because searching commits on the API is very fast, the GitLab API. I don't know about GitHub, but GitLab I've looked into a little bit. What I would do is I would index for sure the merge requests, because that's more limited, right? And tickets, documentation, that's all stuff that we have in GitLab. And the commits are, I mean, Cyril, you have kind of made this gesture. Maybe you have an idea or... Okay. I didn't want to put you on the spot. I'm sorry. I just think.
But also for merge requests, the plan will be that this somehow done automatically under the hood update.
Well, I would do that. What I would do is, like, my idea is to update the index maybe once or twice a day, and then the delta, like with the dates to check it. And I just think the commits are it's gonna explode probably, but we would have to see. Maybe it's actually not too bad, you know.
That would be very useful. I mean, especially commit messages and a lot of information. Repositories. Yeah. So thinking.
What we could do is maybe have that separately in the same tool with a separate search, and then just query the API of GitLab, for example, right? And then render it in the UI. I mean, there's possibilities, but very good question as well. Did I answer it?
Yeah.
Okay, good. Yeah.
You mentioned there is personalization in the search.
Yeah.
Does the personalization in there means that like the tickets that you last opened are higher ranked?
For example, yeah.
Or it's also like maybe the tickets that are assigned to you, and only if you and like some few others see are basically when you search for those tickets, like only you will see those tickets and not the others.
No, there's no limitation on that, which could be an interesting feature as well. What we could also do, because we have all the assignees or all the participants that have worked on the ticket, we could rank them higher if you were in that list, for example. But that's again in query time, you call it, like while you query, and that's going to be a bit slower maybe. But it's possible to do that. But the tickets, you can see all of them. There's no limitation on that in place at the moment.
Is there could be a use case where one needs to search for like more private information that it's not public, but in public that I mean like internally public?
I mean, it depends on the source system, right? If you have kind of like a confidentiality, mechanism, you would have to take it into account. For example, in GitLab, you can say like this issue is confidential, and very good question as well. I have not thought this through yet, but it would just require more engineering, and also the source system needs to provide that. Or you do it on top. You can also add more data and just say, hey, this is confidential, then a list of users that can read it. Could be a future feature as well. Yeah. Yourself.
Let's assume that this system is now in place at 9. And how do we deal now with the needs of the different stakeholders? Because you said it's very easy to add new systems, but no, didn't say it's easy. You could imagine that you add a lot of new systems. With those new systems, you basically spoil the domain specificity of the search domain by, let's say, git commits, which a normal support domain is not interested in. How do you deal with 50 different needs in the future?
I mean, what I have now in place already is you can choose the source system, for example, or the type, tickets. You could also limit it to wiki, or maybe a list. Currently, there's only ticket because that's the only thing I did. I think I'm answering part of your question only, right? The other part was, can you repeat it? I'm sorry.
Assume Cyril comes and says, hey, I need this new feature.
Yeah.
How do you separate this from all the other people who are already working with the tool and used to it? It's more a improvement process question, I guess.
Well, I think different types of information should be stored. Also, it requires engineering, right? Because if you have wiki, it doesn't make sense. A wiki, it doesn't make sense to show these information, all of these information here, right? That doesn't make sense. So you would need to anyway separate it somehow from the rest. With different types of information that should be viewed differently in the tool. But I think I'm still dodging your question, right? I'm sorry, I cannot come.
It's rather a prioritization question then.
I guess so, yeah.
You are the product owner, right? Of Scout, or who is it? Who will decide what will go into it, what's configurable, what will be in a widget on a separate page?
So you're more interested in the development aspect of it more.
Change
Okay.
requests, let's say.
Yeah, we have milestones. It's now I'm talking about the company structure more or less of the development with milestones, and we have to adhere to them. But also what is relevant is the biggest stakeholder of the project is our support. So we already had a conversation about this, and I think information such as docs.9.ch is very interesting and important to be able to search for. Yeah, but it's more the milestones are more company wide, and then we decide in the team more or less when we do what in the planning and the backlog grooming. Yeah, but I don't know if I'm the main. I programmed it, but I think it's our team more or less. Like the software infrastructure team. Yeah. Did I now answer it?
Yes.
Okay, good. It makes me happy. Antonius.
How long does it take for a new Jira ticket to pop up in the search results?
At the moment it won't, because it's not in production yet, right? But no, but for Jira, Jira is we still use it. I was assuming for the thesis that we don't use it anymore, right? That was an assumption I had to make it simpler. But Jira will be, the data you see should be immediately available because you're going on the database of Jira directly. And the index is going to be updated once or twice a day, depending on how fast it's going to be. Because if I'd only do the delta, I could probably do it every hour, maybe. But if you add a comment, it should be immediately there. That's the idea, essentially. I think there was a question there, yeah.
A question about runtime costs. So you mentioned, first of all, cost saving, right? And then there is indexing. For example, if you're integrating GitHub, I don't know how the indexing works, but I imagine you have to do a lot of calls, perhaps it costs something. Have you thought of that, and how much it's relevant to maybe integration cost versus maintenance cost? Have you thought of that? And is it a problem, or would it be a problem if GitHub and Jira is big, or that is huge?
Are you also talking about API limitations, maybe?
Just the cost of doing the calls against API. costs? You need a cost.
Well, GitLab we host ourselves, as far as I'm aware. I think. Yeah. Okay. I have a lot of nods. So yes. So that's not going to cost us. GitHub, I have not thought of it yet, but we don't have that much stuff on GitHub, as far as I'm aware. And like NCTL is on there, I think, right? Yeah. But no, I have not thought about that because so far I have not used an API except for the GitLab one. But it's we should take that into consideration because the cost of adding a new system should not overshadow the cost of that you're saving because you're not running the old system anymore, right? So yeah, no, but it's an evaluation. It needs to be done at some point. Yeah. Any more questions? Okay. I'd like to thank you again, and yeah, that was it.